Hi, here we are going to see about the Unit 1 continuation. Let me see one by one. So the discrete time system is called static or memoryless, and if the output will be known as the instant n. So it should be having these samples at the same time, and the past or future samples will be the input part. Okay. So for example, y of n is equal to ax of n. Next, dynamic system. So dynamic system means that is the discrete time system which will having the output of y of n that will be depends on past and future samples of input. The output will be depends on the past value of the input. So that will be requires the memory. So y of n is equal to x of n minus 1 plus x of n minus 2. Next thing will be the casual and non-casual system. Casual system means that is if the output of the system will be having the any time n, that is y of n depends only on present and past input, that is x of n minus 1, x of n minus 2, etc. but does not depend on future input, that is x of n plus 1, x of n plus 2, etc. In mathematical terms, the output will be having the equation that will satisfy y of n is equal to f of x of n, x of n minus 1 into x of n minus 2, etc. where f is some arbitrary function, that is y of n is equal to x of n plus x of n minus 1. Non-casual means that is if the output of the system will be depends on future input, that is it will be the non-casual or anticipatory system. Y of n is equal to x of 2n. Next thing will be the linear system and non-linear system. Linear system means that it will satisfy the superposition principle. So it states that the response of the system to be weighted sum of signals that will be equal to the corresponding weighted sum of response. So the system is a linear if and only if, that is t of a1 a1 x1 of n plus a2 x2 of n, that is equal to a1 t x1 of n plus a2 t x2 of n. Here x1 of n and x2 of n are arbitrary input sequences, where x1 of n and x2 of n are arbitrary input sequence, that is a1 and a2 are any arbitrary constants. So example is y of n is equal to nx of n. For nonlinear systems, that is the system will not satisfy the superposition principle, that is called nonlinear systems. T a1 x1 of n plus a2 x2 of n is not equal to a1 t x1 of n plus a2 t x2 of n. So for example, that is y of n is equal to ax of n plus b. Next is the time variant and time invariant system. So that is the relaxed system t is a time invariant or shift invariant if and only if x of n t is equal to y of n, that is x of n minus k into t is equal to y of n minus k. So for every input signals x of n and every time shift is k. In other words, the system is said to be time invariant or shift invariant system. Okay. That is y of n comma k is equal to y of n minus k. For example, differentiator. Next we are going to see about the time variant. That is the system is said to be time variant if the characteristics of the system will be changed with time. So that is y of n comma k is not equal to y of n minus k. If it is stable or unstable system means, that is the stable means an arbitrary relaxed system is said to be bounded inputs, bounded output. So if there is a bounded input, it will produce the bounded output. So there is summation n is equal to minus infinity to infinity, modulus of h of n is less than infinity. If it is unstable means if the sum bounded input sequences, that is x of n, the output is unbounded and it is classified as unstable. So for that we are going to see about one problem. So find whether the following systems are static or dynamic. So the question is y of n is equal to x of n into x of n minus 1, and another one is y of n is equal to x squared of n plus x of n. So here y of n is equal to x of n minus 1. So y of n will be depends on the past input, that is known as dynamic. In this second question, y of n is equal to x squared of n plus x of n. Here the output y of n will be depends on the present input only. So it is a system is static. Next question, test whether the following systems are casual or non-casual. So there is y of n is equal to x of n plus 1 by x of n minus 1. So here first we have to put n is equal to 1. So when you are substituting a 1, y of minus 1 is equal to x of minus 1 plus 1 by x of minus 2. So next, for n is equal to 0 means y of 0 is equal to x of 0 plus 1 by x of minus 1. Next is for n is equal to 1 means that is y of n1 is equal to x of 1 plus 1 by x of 0. So for all the values, the output will be depends on present and past inputs. So y of n is equal to x of n squared. So we have to given the output of the system, that is y of n is equal to x of n squared. So for n equal to minus 1 means y of minus 1 is equal to x of 1. Y of n is equal to 0 means y of 0 is equal to x of 0. So if n equal to 1 means y of 1 is equal to x of 1. For all the values, the output will be depends on future input only. So the system is non-casual. Okay. So the next sum is determine if the system will be described by the following input or output equation, which is linear or non-linear. Okay. So here we have taken the question as y of n is equal to x of n plus 1 by x of n minus 1. So here I am having two input sequences, x1 of n and x2 of n. So first we have to find out the y1 of n, that is t of x1 of n. So x1 of n plus x1 by x1 of n minus 1. If y2 of n means t of x2 of n, that is x2 of n plus 1 by x2 of n minus 1. So then we have to sum up the two inputs. So y3 of n is equal to t into a1 of x1 of n plus a2 x2 of n, that is a1 x1 of n plus 1 by a1 x1 of n minus 1 plus a2 x2 of n plus 1 by a2 x2 of n minus 1. So the linear combinations will be a1 y1 of n plus a2 y2 of n is equal to a1 x1 of n plus a1 by x1 of n minus 1 plus a2 x2 of n plus a2 by x2 of n minus 1. So both the equation third and fourth are not equal. So the system is non-linear system. So next is y of n is equal to n x of n. So that is given output of the system is we have to take two input sequences. y1 of n is equal to t x1 of n, that is equal to n x1 of n. Next is y2 of n is equal to t x2 of n, that is n x2 of n. So we have to take the output due to the weighted sum of inputs. So y3 of n is equal to t a1 x1 of n plus a2 x2 of n. So that is a1 x1 or n x1 of n plus a2 n x2 of n. Next we have to say the linear combination of two outputs. So that is a1 y1 of n plus a2 y2 of n is equal to a1 n x1 of n plus a2 n x2 of n. So here the equation 3 and 4 are equal. So the system is linear system. Next is the following systems are time invariant or time variant. So that is the y of n is equal to x of n plus x of n minus 1 and y of n is equal to x of minus n. So that is if the input is delayed the k units in the time, we have y of n comma k is equal to x of n minus k plus x of n minus k minus 1. So the output is delayed by k units in time. Next y of n minus k is equal to x of n minus k plus x of n minus k minus 1. So that is y of n comma k is equal to y of n minus k. So the system is time invariant. Next question is y of n is equal to x of minus n. Here the input is delayed by k units. So y of n comma k is equal to x of minus n minus k. Next is output is delayed by k units. So y of n minus k is equal to x of minus n plus k. So that is the y of n comma k is not equal to y of n minus k. So the system is time variant. So we have to test the stability of the system whose input impulses h of n is equal to 1 by 2 modulus u of n. So here we are going to see the solution. So that is n is equal to summation n equal to minus infinity to infinity, h of n is less than or equal to infinity. So that is summation n equal to minus infinity to infinity modulus of 1 by 2 the whole power n into u of n. So summation n equal to 0 to infinity modulus of 1 by 2 the whole power n. So that is 1 plus 1 by 2 plus 1 by 4 plus etc. up to infinity. So that will be written as 1 by 1 minus 1 by 2. So that is 2 is less than infinity. So the system is stable. Next we are going to see the problem as test if the following systems are stable or not. So y of n is equal to x of n u of n. So that is the input is x of n is bounded. So modulus x of n is less than or equal to m. So y of n is modulus x of n into u of n. So the system is stable. So next thing is the output of this y of n is equal to x of n plus n x of n plus 1. So here the x of n is less than or equal to m. So y of n is equal to modulus x of n plus n x of n plus 1. So the system is increasing n. So it is unbounded output. So the system is unstable. Next is the discrete Fourier transform. That is the sequence x of k is called the endpoint DFT of x of n. So these coefficients are related to x of n as follows. That is x of k is equal to summation n is equal to 0 to n minus 1. So x of n into e power minus j 2 pi k n by n. So that is k value is 0, 1, n minus 1 etc. So the endpoint IDFT of the sequence is x of n is equal to 1 by n summation a k equal to 0 to n minus 1 x of k e power j 2 pi k n by n. So n is equal to 0, 1 etc. up to n minus 1. So that is x of k is equal to means compute the DFT of the 4-point sequence, that is x of n is 0, 1, 2, 3. So first we have to submit the values in one by one in equation, that is x of k is equal to summation n equal to 0 to infinity x of n e power minus j 2 pi k n by n. So that is x of 0 is 0 plus 1 plus 2 plus 3, that is 6. Okay, x of 1 is equal to summation n equal to 0 to 3 x of n e power minus j 2 pi k n by 2. So that is 0 plus 1 minus j plus 2 minus 1 plus 3 j, that is 2 minus 2 plus j2. So likewise we have to substitute the value of 2 and then 3. So that is the final answer will be the x of k is equal to 6 minus 2 plus j2 minus 2 minus 2 minus 2 minus j2. Okay. Next problem is that is we have to find out the values, that is x of k is equal to summation n equal to 0 to infinity x of n e power minus j pi k n by 4. So that is k equal to 0, 1, 2 etc. up to n minus 1. So first we have to substitute k equal to 0. So that is x of 0 is equal to summation n equal to 0 to 7 x of n. So there is 0, 1, 2, 3, 4, 5, 6, 7. We have to put the values and find out the answer. Next for k is equal to 1. So that is x of 1 is equal to summation n equal to 0 to 7 x of n e power minus j pi n k by 4. So when we are substituting the values n equal to 0, 1, 2, 3, we will get the values. After that we have to find out the answer. That is minus 0.707 minus j 1.707. Next for k equal to 1, 2, we have to substitute, we will get the answer as 1 minus j. And if the k is equal to 3 means, we get the answer as 0.707 plus j 0.293. Next substitute k equal to 4, so we will get the answer as 0. And k equal to 5 means we get the answer as 0.707 minus j 0.293. Then k equal to 6 means we will get the answer as 1 plus j. And the last is we have to substitute up to 7. So k equal to 7 means the answer is minus 0.707 plus j 1.707. Next the x of k is we have to consolidate all the values and write it in the one way. Okay.